This video will provide an introduction to daylighting in OpenStudio and Energy Plus. Here I have a simple model with two spaces defined already with constructions, internal loads, schedules, and so on assigned. Spaces are identical, save for being mirror images of each other where they share a center wall. Each space is assigned to one zone. And for daylighting to work in Energy Plus, you must first have electric lighting set up for your zone. What it will do is when you run the simulation, once you put in the appropriate objects, Energy Plus will calculate the illuminance from natural lighting in the space, compare that to the required illuminance from the electric lighting, and reduce the lighting output accordingly based on the parameters that you've set up with your daylighting controls. So the first thing we'll do is put in an illuminance map in the zone that we want to assign the daylighting to. We're going to use this zone here on the right. One thing that's really helpful when you're working with daylighting is to use the section tool from SketchUp. Selected that here. I'm going to hover until it turns blue so it's horizontal, hold shift so it stays horizontal, and then come in and click within my space above the level that I think I'd like my illuminance map to sit at, and then cut my space. In fact, I think I'm going to move that up just a little bit to make sure it's above where my illuminance map goes. I'm going to double click to edit the space. And the first object I'll put in is the illuminance map that I just mentioned. It's this tool here. Come over, I'll click somewhere within my space, snap there, and I can see that right now it's outside the space, but it came in a little bit above the floor. Sometimes it will come in at a height of about 2.5 feet, which is generally where you want it to be. Sometimes it'll come in flush with the floor. So the first thing I would do if it was an incorrect height, oops, turn off my section plane here. Space again. If it wasn't the height where I wanted it, the easiest way to adjust the height is to adjust the Z coordinate over here in the inspector window. So right now it's at 2.5 feet, which is where I want it. Let's say I wanted it at 3 feet, then I could just adjust it there and move it back down to 2.5 feet. Obviously it's not sized properly for the space at the moment. The easiest way to adjust its size is to first set your camera projection to parallel projection and then go to a top view of the model, so you're looking at it directly in plan. Whoops. And then I'm going to once again edit my space, select my illuminance map, and then select the SketchUp scale tool, which is here. And then I'm going to scale it to match, here I'm making it match the width of my space. I want to leave a little border around it. I don't want it in contact with the actual exterior wall, because sometimes light will leak through the wall. That happens. So there we go. That looks like a pretty good size. Now that I have it positioned, if I look at my inspector on the illuminance map, I can set the number of X grid points and number of Y grid points. So this essentially controls the resolution of the daylight simulation, the number of sample points. When you run the simulation, you're going to get a value for each one of these grid spaces. That, of course, increases the calculation time pretty substantially the more of those you have. So you want to set it so you get enough fidelity to get the information you need without overwhelming the simulation in terms of the time it takes to run. All right, so I have my illuminance map placed, and it looks pretty good. The other tool that I need to trigger the daylight simulation in OpenStudio is a daylight control, which is this object here. I'm going to go ahead and double click and edit my space one more time. Pivot around. I think I can get the one in there that I want to begin with. Select my daylight control. And you can have up to 2 per zone. Generally, we'll put one in a larger room, one closer to the windows to control a zone of lighting that is more directly affected by the natural lighting, and one further away from the windows to control the rest of the lighting. Here, it looks like it came in pretty low. Again, I'll adjust the height. I use my inspector to do that. Putting in a Z coordinate and put it at 2.5 feet again. Now this control doesn't represent the actual sensor, it represents the point at which the sensor is pointing or aiming. So the sensor would probably be mounted on the ceiling, but this is where we want the measurement to occur. Notice that it's also got a couple of arrows here. The horizontal arrow is going to be the direction that it calculates glare for, and the vertical arrow is the normal direction or up. So I want to point the glare sensor toward the window. So I'm going to change the phi rotation around the z-axis to 180 degrees, and now it's pointing toward the window. I'm going to switch my camera back to perspective because it's a little bit easier for me to operate that way. So typically these sensors would go at approximately the third dimension points within the room. I had 15 grid cells here. So I'm going to move mine back, let's say to about here. That'll control the front lighting zone. Now I'm going to insert another one, which is not required, but it is allowed. Back here toward the back. Again, I'm going to position it above the floor. Set its direction. All right, so let's check the naming of these objects. That's a luminance map 1. First one is daylighting control 1. The second one is daylighting control 2. All right, so let's look at our properties here on the controls. Notice that it's got an illuminance set point by default of about 46 foot candles. This is your design illuminance level, and the algorithm is going to assume that when the lights that you've already defined are on at 100% power, they provide exactly the illuminance that you've designed for. So 46 foot candles is fairly typical for an office type space as a design value. Many people find it to be on the high side of what's necessary, particularly if we're using strategies like task lighting and more finer grain strategies. You could certainly go well below 46 foot candles. That's equivalent to roughly 460 lux. I'm going to set that down. Let's say in this case I'd like about 30 foot candles. The lighting control type controls the way the light is adjusted. Continuous is fine in most cases today. There are some controls where they adjust in steps rather than a continuous adjustment. The minimum input power fraction is the lowest level the lights can dim to before they go off. So the default is 30%. and then the maximum allowable discomfort glare index, there's a default value of, I believe, 22, and you can look at the Energy Plus documentation for an explanation of what that reflects. If you want to use a different value, then you insert that there. I'll assume that on my other control, I want the same set point, so I'm going to set that here. All right, and then the last thing I want to do within the SketchUp plugin, I'm going to save my model first off. And if I look at my zones, I want to come down and look at what got attached to the zone. So daylighting control 1 is the primary. It's controlling 50% of the zone. Sometimes that will come in as controlling 100%, and you need to adjust it. Or if your zones are not of equal size, then you need to adjust that. But we're going to assume that the lights are divided into two equal areas in terms of the lighting power inside the room, and go with the 50%. Secondary is daylight control 2, and then the illuminance map is properly defined here. Occasionally the illuminance map will get attached to the incorrect zone, so you just want to make sure that it's properly assigned there. Okay, I'm going to save my model and open it from OpenStudio. Looks like OpenStudio crashed for some reason. Okay, let's try that again. There we go. Okay, from within OpenStudio, once you've added the daylight objects, whoops, I meant to click on variables, you'll have access to a range of variables having to do with daylighting. I've selected all of those here, and I've also asked it to report my cooling load and heating load, as well as the electric energy and electric power from the zone lighting. The other really important thing to check is under simulation settings, simulation control. You want to make sure that you have solar distribution set to full interior and exterior at the minimum, and better is full interior and exterior with reflections. That's going to calculate the distribution of daylighting around the space, including light reflected back off of surfaces using a radiosity type algorithm, and it will use the reflectance value that's defined in the material for your surface finishes. So to adjust the reflectance, you would adjust those values under the materials objects for the constructions that are applicable. It'll also, all of these calculations will be based on the properties of the window, which are defined under the window objects in terms of the visible light transmittance. For the sake of the demonstration, I have just the month of April defined as my run period in order to keep the runtime to a minimum. And if you decide to use the radiance algorithm, which provides you finer grained analysis, the radiance parameters are defined here. There are two options in Energy Plus for daylighting, or rather in OpenStudio for daylighting analysis. Either you can use the built-in Energy Plus algorithm, which is a simplified algorithm, which is good for understanding basic energy savings and so on, to really understand in detail the performance of the daylighting in terms of many other metrics and the experience of the space. Radiance is the best tool to use, and the Radiance software comes built into OpenStudio when you install it. If you want to run Radiance, then you need to load the Radiance measure under Measures. And you find that under electric lighting controls. You'll probably need to download it from the BCL, and it's the Radiance daylighting measure. You drag that in to OpenStudio. Here, I'll do that. And what it will do is it will run the daylighting performance looking at the illuminance level compared to your illuminance set point using Radiance. Then it will write schedules to adjust the electric lighting output based on the Radiance output. So that's why you check here, apply schedules. And then the settings, you can either, you'd want to probably just leave it set to model and then adjust the settings where I just showed in the simulation control page. Running Radiance increases the runtime by a considerable amount, and it also doesn't produce the same kind of illuminance map that I want to show you here in the demonstration, so I'm going to turn that off. I have my OpenStudio results measure applied as well. So I'm going to save, run my simulation. You can see that it ran quite quickly. We also see that it's doing various calculations around the daylight controls here. My simulation is completed. And we'll start by looking at the results in a new data viewer tool, new to us, that we haven't used in the class previously. This was actually the precursor to DView that was included with OpenStudio up to version 2.2. I've uploaded the OpenStudio version 2.2 software installer on the Box distributed folder under Reference. You can install this, but all you need to install is just the results viewer component, not the entire OpenStudio package. Once you do that, you can open Results Viewer, and this has a key capability for daylighting that wasn't built into DView. So I'm going to, from Results Viewer, open my SQL file that was generated as part of my run. So I'm going to navigate to the directory associated with my OpenStudio file. Go to Run, and then e+out.sql. It's going to give you an error saying it doesn't know this version of Energy Plus, but in my experience, it still works just fine. Then if we go to Tree View and scroll down until you get to the illuminance map. So you'd have a different illuminance map for each daylit zone. In my case, I've only got one, so I've got one illuminance map here. If I double click on it, it shows me the illuminance map for this space. So you can kind of guess here, this is the side where the window is. This is the opposite side. If we had bilateral lighting, we'd see light coming in from different directions. And it's showing me here currently April 1st at 7 a.m. So if I scroll through the hours, I'll see that daylight distribution changing. And we can see that it's kind of moving as we get further to the afternoon, as the sun's moving over to the west. Now here on April 15th, if I scroll through the day, as we go through here, you might think that illumination is decreasing based on the false color diagram as we proceed through the hours of the day. But notice how the vertical scale changes as I click on each subsequent hour. Go back to the morning. I put my value info mode tool here. And so we've got, at this particular point I chose, we've got 151 lux at 7 a.m. Notice as we go on, even though the color scale is shifting, it makes it look as though there's less luminance back here. We can see it's actually going up. So we're at 380 lux, roughly. There, going up to 500, 600. So as we go through the afternoon, it actually increases up until early afternoon, and then starts being reduced again as that light level is more uniform across the depth of the space. So be careful about looking at the scale and checking what the actual values are, and you can always use your value info tool to actually check the values at different points in the space. So these maps are really helpful to understand what's going on in your space. You can either export an image of this using this Save Image tool, or you can take a screenshot of it to capture these for later. Make sure that you pay attention to the orientation. This will generally be the green axis direction, which is often north, but if you built your model differently, then that will change as well. All right, now looking back at DView again, I'm going to go back to my OpenStudio model, then open DView. I'm not going to translate it to IP units this time. There are a lot of things we can look at here to understand what's going on with the daylighting between all the variables that I've requested here. I'm going to start by looking at the lighting energy, compare my two zones, and see if the daylighting is having the effect that we would hope. So I'm going to select my daylight control zone and my no daylight control zone. And if I zoom in here, this is energy. Actually, rather than energy, let's look at power to start with. Shape of the graph looks pretty similar. I can see this regular pattern where I have no daylight controls. The lights come on, they run at my defined power for a certain period of time, and then that power ramps down based on my schedule. In the daylight controlled zone, we see the lights coming on early in the morning, but as the daylight level increases, then that power level correspondingly decreases. Remember, this is for the entire zone, so we might have the lights fully off for a time period in the daylit portion of the zone, daylight control 1, but they're still on for much of the day in daylight control 2's area. In fact, we can look at what's going on there. Let's look at our illuminance for daylight control reference point 1 here. Oops, put it on the other graph. And then 2. So we can see that control point 1 is getting significantly greater illuminance, and we can also see how that reduction in lighting power corresponds with the increase in illuminance within that area. All right, let's turn those off. Let's also look at what's going on with the heating and cooling loads. We're probably in cooling period right here because we're in April in an internally load dominated space, very likely being an office space. So I'm going to check the cooling load. And I can see that we're looking like at our peak times, and actually probably fairly consistently, we're seeing on the order of these hotter days, probably a 30 to 40% reduction in the cooling load based on that reduction in electric lighting. So we're having a really significant effect here based on the daylighting. One more way we can look at it is we could look at our monthly light energy and compare our two zones. Oh no, it's not liking that. But we can compare the daily total, and we can see that we're seeing a really significant reduction in lighting energy as a result of the daylighting. So you can explore the rest of these variables and ways to understand what's going on with your daylighting and what its impact on the space is. But these are some examples.